Hey kids, this is Mr. T and I'm going to show you how to make what I call a water tub out of paper and tape. So this is an instructional video just to remind you of what to do. So these are the materials that you will have. You're going to have a sheet of paper. It'll probably be this sort of thick paper called cardstock. I'm going to give you not a whole roll but a single piece of tape, and then you'll have access to some scissors and and a ruler as well. So there should be a ruler. Here it is. Okay. I'm calculating. So definitely, this is a math class, and we'll be using some numbers and doing some calculating and that kind of thing. So my recommendation is that you use your sheet of paper like this, where you cut out these little squares. And the idea is that we're using a sheet of paper to actually hold some water. And if you think about something holding water, it's like, well, I don't know if a sheet of paper is going to do that. But the reality is we can create something. And I kind of recommend you do this. So we had a rectangular sheet of paper, and the sheet of paper is normally 8.5 by 11 is what it's called. So that will be 8.5 inches by 11 inches. And your mission, should you choose to accept it, is to create a container that holds the most amount of water. So we'll have some prizes for the groups or individuals with the containers that hold the most amount of water. And if you cut squares out of the corners, and if the squares are the same size, we might even use our algebra skills and call those distances x. Then we can create a container. So before we do that, I'm just going to show you kind of what we're going to do in terms of the calculating. So if the length of this side is 11 inches, and we just took x and x away from it, what do you think we would have for the length of this side? So now you're thinking, and you know I'm going to tell you, which I'm going to do, so here goes. So it'd be 11, and we took away an x and an x, so we took away two x's. And if we were looking for the length of this little segment, well, it was 8.5 inches, and we took away x and we took away x, so we are left with, so this would be 8.5 minus 2x. So if we, let's see, 11 minus 2x, alright, so if we were to sort of use our art skills and draw out this container, it might look something like this. So that's behind, right? Oops, oh gosh. And we would have the height being x, and this short side over here was 8.5 minus 2x, and our long side was 11 minus 2x. So you may recall that the volume of a rectangular solid, which is the volume of a box, is length times width times height. Length times width times height, where we have length, width, and height. So if we were to write this expression, we have our length times our width times our height. And I'm going to write that in front just because that's normally how it's written. And so if this looks suspiciously like a polynomial equation like we've been doing, good work, that it is. So let's use this as our formula for volume. And before you actually cut your paper, you're probably going to want to do some sort of thinking and some calculating to see how you can hold the most amount of water, because once you cut the sheet of paper, that's it, and it's a certain box. And if x is very small, let's take a look at what would happen. If x were very small, so here's your sheet of paper, and if you cut these little squares out of the corners, right, you'd have a little edge to fold up. So the bottom, that's this, the bottom would be very large, but the sides would be very short. So you'd have something that looks like this. And I don't know if that would hold that much water. And so you think, well, I'm just going to cut some huge corners out. All right, so X is very large, and you cut out these huge corners, because my box will be really tall. And that's a good idea, except look at what happens. Here's this, when we fold it up, okay, this is the bottom. Oh my goodness. So you'd have this really small, really tall, but really skinny box like that. And I don't know if that would hold a lot of water either. So here's our water level in there. So I think for something in the middle where we take our rectangle and we cut some squares. I wonder how big to cut them. I'm going to put little question marks in there. And we end up with something like this that hopefully holds the most amount of water that we can. So we're going to experiment with this. Let's see how this works. So, all right. So we go back to the original thing. This is where I cut the little squares out. And I'm folding the edges, and I'm using a little bit of tape on the edges. You think, paper holding water? Yeah, totally. And we don't even need that much tape, okay? You can't just cover the whole thing in duct tape and call it good. So I am sealing the corners, and notice how I left a little bit. This is the bottom of the box. Notice how I left a little bit of tape so I can fold that over and get a nice in the corner. Ah, that looks good. All right, so no water is going to escape. The piece of tape went all the way out to the edge, and I'm going to tape the other four corners. So it's just these little pieces of tape and a sheet of paper to make this box that should hold some water. We'll see. Ah, so finished product. You know, maybe I could have decorated it or something like that, but the idea is we're now going to pour some water into, and we're going to measure how much. So when you're doing this over here, you're going to have your lab paper, and you of course will be taking data, and part of the data is going to be X, how much of the paper you cut out. Alright, so we're looking for that distance, which ends up being the height. So we're looking for that, but we're also looking for how much water we can actually fit inside. So you're going to have some container. I think the one that I'm going to show you is 200 milliliters. This is a way of measuring volume or amount of water, just like miles measures distance and seconds measures time. So you're going to have some container, and you're going to count in your data. You'll be writing down how much of these you can actually pour into your container. And when we do this, we're not going to be doing this on the desks or not over an iPad or whatever. We'll make sure that the water doesn't spill. So, aha, here I am measuring the amount of water. So this was up by 500 milliliters. That's kind of, oh, this looks better. So this little beaker, this was 200 milliliters. And I think I was able to fit a couple of these in to my container. Ah, yeah. So notice the bin, so I don't spill. Well, so that if I do spill, it's fine, and then I can just dump that into the sink. And this was the 200 milliliter beaker, and here's my box, and I am filling it up with water. So I think I was able to get about 4 of these into the box. And ideally, you'd keep an accurate amount or an accurate count. So I was able to fill 4 of the 200 milliliters, and then maybe it was an additional 30 milliliters or something like that, which you could see on the side of the measuring device. So that would give us a total of 830 milliliters, and that would be the volume that I could actually fit into my container. So the water started spilling out the side here like this. So once it starts spilling, you know, stop pouring water. That was as much as you could do. So good luck, and give this some thought before you cut the paper.